Very good morning to all. I am Dr.C.Senthilkumar, Associate Professor, Department of Mechanical Engineering. So in this lecture video, I am going to deliberate about the conduction, which is in the unit of number 1, that is conduction heat transfer for the 6th semester students of BE Mechanical Engineering. The subject is 23 MEB 302 heat and mass transfer. So let me recall the previous study related to the thermal engineering. So we know the thermodynamics. So thermo means the heat, dynamics means movement. Movement of heat is said to be thermodynamics. Here it is related to the heat transfer. Heat transfer is a branch of thermodynamics in which also we have thermodynamics concept and principles which are applied in the heat transfer concept. We know that transfer, it is nothing but transport. When we transfer something, that is said to be transfer general word. When we transfer the heat, that is said to be heat transfer. So laws of thermodynamics that we know, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. The laws belongs to the UG studies, first and second law. So the second law related to the heat and mass transfer is Kelvin-Planck statement. So how that plays a role, where we see in the upcoming slide. Heat dynamics, when the heat is moving, that is said to be heat dynamics. When the heat is in statics, which is in the static condition. Let me go for the next slide. So these are the topics we are going to see related to the today's presentation. Introduction, DT stages, thermodynamics, heat transfer, modes of heat transfer, mechanism of heat conduction. So let me see the concept related to the design thinking. So we SNSCT first implemented Indian Institute of this design thinking concept. Empathize, define, ideate, prototype and testing. Understanding the problem. In case of empathize, related to thermal problems and defining the requirements, how it is needed to be applied, that we define here. And in idea, we'll have a brainstorming and find out where it will be applied for the thermal applications. We produce a product, that is prototype. So after producing a prototype, we'll test and evaluate it. So these are the 5 stages of design thinking we are going to implement in this lesson also. So first let me see the mechanism of conduction. So conduction, already we know that conduction is nothing but transfer of heat between metal to metal. When the metal is transferring heat from one point to another point, that is said to be conduction mode of heat transfer. So what is the mechanism behind that? These are the mechanisms. Conduction in metals, it takes due to the free electrons, which is high thermal conductivity. We can say copper, the another crystal is a diamond. So medium thermal conductivity or moderate thermal conductive materials are semiconductors, which has more number of holes and a medium number of electrons. In case of high thermal conductivity, we can note that more number of free electrons are there, so that high thermal conductivity is achieved. So coming to the conduction insulator, which is vibrating atom, so which is having less thermal conductivity. So thermal conductivity plays vital role in the conduction heat transfer. So coming to the thermal conductivity of material properties. So a measure of material's ability to conduct a heat, it is denoted in the unit watts per meter Kelvin. For solids and fluids generally have higher conductivity, as we seen in the previous slide. For insulator, which is having lower thermal conductivity due to holes and free electrons less. Okay. So let me see high thermal conductive material, diamond as we said, and copper also. So coming to the governing law related to the conduction, that is Fourier law of heat conduction, which is nothing but Q equal to minus Ka dt by dx. We know what is K. K is a thermal conductivity. A is the cross-section area. dt by dx is the temperature gradient. So here, the thermal conductivity watts per meter Kelvin K, which decides how much the material can transfer the heat. The law governs the product of these all values. That negative sign here in this governing equation indicates that reduction in temperature along the length of the component. If a product is supplied with certain amount of heat, after a certain distance it loses the temperature. So this is what the governing law of conduction, that is nothing but Fourier law of heat conduction. Let me go for the next slide. So let me recall. So analogy for understanding modes of heat transfer, the first concept is conduction from metal to metal while heating. milk water in the pan which is conducting the heat one point to another point in a metal, that is said to be conduction. So this is the summary of the concept. This is the summary of the concept: introduction, DT stages, thermodynamics, heat transfer, three modes of heat transfer, mechanism of conduction. And curiosity challenge about this concept we can have 2 minute discussion with peer is how the uh, mode of which mode makes more heat transfer, that you can think along with your friend circle, because three modes are there we discussed already. In this we have discussed about the conduction. We can think about the modes of the heat transfer. Coming to the assessment, so heat transfer by conduction takes place mainly due to option: bulk motion of molecule, free electrons and molecular vibration, electromagnetic waves, fluid circulation. So the correct answer is free electrons and molecular vibration. Which of the following is not a mode of heat transfer? We know the modes of heat transfers are three: conduction, convection and radiation. Here the evaporation is odd man out. So the evaporation is the not a mode of heat transfer. Let me check the answers also. So B and D. So these are my references, and thank you very much for listening my lecture and give your valuable input for improvement. Thank you.